Sorry, good morning. Okay, so we will enter to our last chapter, chapter number 9. So, mechanism of heat transfer. So, today we will cover part 1 and part 2. Okay, so there are some information that you can get from here. So, your exam covers until chapter 9. So, there are some questions from heat transfer. So, we will just go through some of the important things that involved with heat transfer. Okay, so as an introduction, okay, heat is a form of energy that can be transferred from one system to another system as a result of temperature difference. Okay, so kita tahu ada dua benda, okay, dalam energy transfer. One is work, one more is heat. Okay, aba dan kerja. So kalau dia berkaitan dengan temperature difference, so if it's related to temperature difference, so meaning T1, T2, so there's a difference, so it is automatically considered as heat. Okay, so kalau dalam exam ditanya apa perbezaan antara heat and work, so you know that heat is something related to temperature difference. Okay, energy transfer related to temperature difference. Okay, so these two terms, so you always will see thermodynamics. So thermodynamics means so deal with the amount. Okay, berapa banyak energy yang transfer. So that is what related to thermodynamic. Okay, so kalau ada dengar perkataan thermodynamic, dia bermaksud amount, berapa banyak, okay, of energy. So it can be energy in the form of heat, it can be in the form of work, so and also it can be in mass. Okay, mass transport. So something related to open system. Okay, so no indication about how long. Okay, how long the process will take. So okay, so thermodynamic dia berkaitan dengan amount, berapa banyak, berapa lama tu is something related to heat transfer. Okay, so heat transfer deals with determination of the rates of such. So rates apa tu? Rate, kadar. Kadar tu apa? Berkaitan dengan apa? Masa. So kadar. So dalam 1 minit berapa banyak amount transfer. So dalam 1 jam berapa banyak transfer. Okay, in 1 day berapa banyak transfer. So there's something to do with rate. Okay, so perbezaan antara thermodynamic and heat transfer. So the differences. So thermodynamics deals with amount, berapa banyak, and heat transfer is something related to time. Okay, dalam jangka masa ini berapa banyak yang transfer. Okay, so we not take into consideration the amount dalam heat transfer ni. Okay, so dia berkaitan dengan masa. Okay, so the transfer of energy as heat is always from higher temperature medium to lower temperature. Okay, so yang ni secara natural. So as a natural, so you only can reduce the temperature from high to low. So dari low tak boleh jadikan dia high unless the environment is panas. The environment dia panas. Okay, so heat transfer stops when two medium reach the same temperature. So meaning you put a cup 70 degrees, so environment 25 degrees, so you biarkan 2 jam atau 3 jam. So after 2 or 3 hours, so dari 70 dia akan kurang sampai 25. So selepas sampai 25 dia akan kurang jadi 15. Okay, so dia akan ikut persekitaran. Okay, so it can be transferred in 3 different modes: conduction, convection and radiation. I think you have done your lab on this. Okay, conduction and convection. So dia ada 3 cara. Okay, how heat transfer is happen. One is conduction. Conduction dia berkaitan dengan physical. So apa-apa yang bersentuhan. So apa-apa yang so it can be from environment sentuh dengan some surface. So it still considered as conduction. So convection dia kena ada motion. So ada buat eksperimen kan yang berkaitan on angin kipas. So ada angin. So there's a motion in fluid. Okay, because of the what motion lah, fluid motion. Okay, so radiation dia gunakan electromagnetic macam matahari. So matahari dia nak the heat nak sampai dekat bumi, so it is passing through electromagnetic wave baru sampai. So yang ni dia tak berkaitan dengan conduction or convection. Okay, so this is simply about conduction, convection and radiation. So kita akan tengok apa itu conduction. So today we will see all the three types of mode. Okay, conduction, convection and also radiation. Okay, so apa itu conduction? So what is conduction? Conduction is the transfer of energy from one energy particle of a substance to adjacent less energetic ones as the result of interaction. So keyword untuk conduction adalah interaction. Interaction maksudnya apa? What is the meaning of interaction? So interaction kena ada physical contact, macam bersentuhan. So you letak cup, dari cup transfer ke meja, so that's a physical contact. So that is what we call as a conduction. Must have a physical contact. Okay, so in gases and liquids, conduction or heat conduction is due to the collision and diffusion of the molecules. Okay, yang ni kalau kita tengok microscopic, so inside what is happening? So the molecules are colliding or diffuse. Dia berlanggar ataupun dia bergerak jauh. Okay, so that's the interaction. So in gas and liquid it happen because of that. Tapi dalam solid dia ada lattice. Lattice maksudnya susunan. So molecule memang dalam susunan. So it's vibrating about the same place. Okay, so vibration of the molecule. Okay, in the lattice. Lattice maksudnya susunan. Okay, the energy transport it by free electrons. Okay, so in between ada free electron, itu yang akan transfer the energy. So a cold canned drink in a warm room, for example, eventually warms up to the room temperature as a result of heat transfer from the room to the drink through the aluminium can by conduction. Okay, so kalau you letak satu can, okay, so Coca-Cola, so letak yang sejuk, so let's say is 20 degrees Celsius, so you letak dekat table. So after some time, so let's say the room temperature is 30 degrees, so dia akan eventually receive heat transfer. So heat transfer berlaku dari mana? Dari can ke environment ke environment ke can? Environment ke can. So dari environment, so let's say 30 degree, so 10 degree akan pass dekat sini. So maybe after some time dia akan jadi 30 degrees following the environment. Okay, so the rate of heat conduction through a plane layer is proportional to the temperature difference across the layer and transfer area, but is inversely proportional to the thickness of the layer. Yang ni boleh tengok formula dekat sini lah. Okay, so kalau nak kira, okay, so the rate of heat conduction, the heat conduction adalah conduction heat lah. Okay, so kalau nak kira kadar dia, so maksudnya Q dot. Okay, Q dot COND, conduction. Okay, so boleh tulis macam ni. So sama dengan K. K apa tu K? Kita ada dekat sini. So K adalah heat, conduction heat coefficient. Okay, dia adalah satu, selalunya dalam soalan dia akan bagi tahu lah apa value K. Okay, okay, and A adalah area. Okay, area. T1 minus T2 adalah temperature difference, and X adalah thickness. So kalau you ada semua maklumat ni, so you can do the calculation, okay, to find what is the rate of heat conduction. Okay, okay, so K, so value of K, so K is thermal conductivity. K, a measure of the ability of material to conduct heat. Okay, so conduct heat is not absorb heat. So jangan confuse. So conduct heat maksudnya, so dia boleh heat boleh melalui dia. Okay, some material, contohnya macam kalau bandingkan besi, so if you compare iron and wood, okay, kayu. So besi dengan kayu, yang mana lagi besar dia punya thermal conductivity? So which one has a more more thermal conductivity between iron and also wood? Yang mana akan ada? Iron. Okay, so iron. So because iron has more ability of a material to conduct it. Okay, so it boleh melalui dia dengan lagi senang. Okay, compare dengan wood. Okay, so that's the value of K. So temperature gradient dt over dx, the slope of the temperature curve on a Tx diagram. So yang ni Tx diagram tak ada dekat sini lah. Okay, so temperature gradient. Okay, temperature gradient. So it is conducted in the direction of decreasing temperatures, as I say. So dari tinggi akan jadi rendah, and the temperature gradient become negative when temperature decreases with increasing x. So kalau ketebalan lagi tinggi, so temperature tu akan ada banyak laluan lah, sebab dia tebal kan. So kalau dia tebal, so if the material is thick, so dia akan ambil masa untuk dia melalui. Okay, so I think is general lah. Okay, so the negative sign in the equation ensure that heat transfer in the positive x direction is the positive quantity. So you can see here. So kalau you nak lukis waktu exam, you boleh lukis macam ni. So let's say you have thickness. So thickness adalah 1 meter. So you have a wall. Okay, ada dinding. So boleh lukis temperature yang tinggi, lukis dekat atas. Temperature yang rendah, lukis dekat bawah. Okay, so from 30 degrees reduce to 20 degrees. So you want to calculate the heat transfer. Okay, so kalau you tengok dekat sini, yang ni adalah copper. So copper K equals to 401, and silicon K equals to 148. Yang mana thermal conductivity lagi tinggi? Copper ke silicon? Copper, because the value is bigger, 401. Okay, so boleh tengok dekat sini, Q equals to 4010. Tapi untuk dekat sini Q adalah 1480, because the value of K is lesser. Okay, so thermal conductivity, the rate of heat transfer through a unit thickness of material per unit area per unit temperature difference. Yang ni actually dia ambil dari formula ni. Kalau you nak cari apa tu value K, so you rearrange yang ni. Okay, so you akan dapat this explanation. Okay, the thermal conductivity of a material is a measure of the ability of the material to conduct heat. So I dah bagi tahu tadi. Okay, a high value of thermal conductivity indicates that the material is a good heat conductor. So kalau value of K is high, so it's a good heat conductor, meaning dia boleh melalukan apa dengan lagi efficient. Okay, so dengan lebih baik. And low value indicates the material is a poor heat conductor, or kita panggil another term as insulator. Insulator maksudnya dia tak bagi lalu. Okay, so poor heat conductor, dia still bagi lalu tapi sikit, so lesser, but still there's some heat conducted. But insulator, no heat conducted, atau no heat transfer. Okay, you can see the table here. Okay, some of the common materials at the room temperature. Okay, paling bagus adalah diamond. So diamond really can transfer the heat. Okay, yeah, dia boleh letak. So that's why some of the equipments dia gunakan diamond. Okay, diamond because one thing is very hard, it's harder to break, and it's a good heat conductor. Tapi dalam PC semua tak boleh letak diamond lah, so nanti kena curi kan. I think previously semua kebanyakan komponen dalam PC dia gunakan gold. So orang dah mula curi dah. Okay, once people already know that gold is used. Kalau you tengok dekat sini, okay, gold, so the thermal conductivity is still high, 317. Compare dengan diamond, so gold is easily available. Okay, So dia letak sikit gold dalam tu, dia charge dalam agar PC. Okay. So after some time, people already know that even the RAM ataupun processor inside your old PC, they are using gold. So people already start to do processing to remove the gold. Okay. So dapat 1 gram pun sekarang berapa? So 200 plus. Beli PC baru berapa? So that time I think maybe 1000 or 2000. So you get back from the old PC. So kumpul 5 PC dah boleh beli satu PC dah. Okay, so people can regenerate. Okay, so you can see some of the materials. So diamond, silver, copper, gold, aluminium. So all these are under the category of high thermal conductivity. And kalau you tengok dekat bawah, okay, wood, helium, soft rubber, glass fiber, air, urethane, so semua material ni. So even human skin, boleh tengok dekat sini, human skin 0.37. Kalau human skin can really transfer it, habislah. Okay, kita dah jadi apa? So kita dah jadi orang saya. Dragon Ball biasa baca. So jadi macam tu. So badan dah ada api. Okay, so this is the is a similar table, okay, in a form of graph. So you can see, so low heat transfer is gases. So normally kalau you tengok kategori ni, so if you can see all these categories, so gases, insulators and liquids, they are under the low thermal conductivity category. And all these non-metallic crystals like diamond, graphite, silicon, carbide, okay, beryllium oxide, quartz, okay, so pure metal macam silver, copper, iron, manganese, semua ni dia dalam kategori high thermal conductivity. Okay, so you can see here, okay, so this more on the microscopic side. Okay, dalam material. Okay, dalam gas, so in the fluid, okay, in gas, so you can see the molecular collision and molecular diffusion. So molecular collision when two molecules try to join together, so dia akan ada pelanggaran. Okay, diffusion, dia berpisah dari one molecule, berpisah dari satu lagi molecule. Okay, so this on the gas side. So liquid, it happen at the same thing but at the closer range. Okay, sebab dia liquid lagi padat. Okay, and solid, so it has a lattice vibration. So ada vibration at the same place, so that's a lattice vibration, and flow of a free electron. So in between ada electrons. Okay, yang ni benda yang sama lah. Okay, so it's mentioning about the same thing. Okay, so thermal conductivity of gases. Okay, so earlier we saw in general, yang ni based on the gases. Okay, kalau gas, you boleh tengok dekat sini. Okay, gas normally occupies the lower graph, dekat bawah ni. Okay, so pure metal, crystal and metal have high thermal conductivity, and gases and insulating material are the lowest. Okay, boleh tengok dari gambar ni lah, graph. So on top more on the solid side, down here more on the gases, okay, and also the liquids. Okay, so tadi kita tengok thermal conductivity. So another term, thermal diffusivity. Okay, what is thermal diffusivity? Okay, how fast it diffuses through a material. Okay, tadi it is transferred, so dia boleh melalui material tu. Okay, thermal diffusivity meaning how fast the heat is released from the material. So whether the material can absorb it or not. So kalau low thermal diffusivity, so meaning the material can absorb it. So tadi lalu dia simpan. Dia tak bagi lalu terus. Dia simpan dulu. Okay, macam bateri lah, macam let's say macam bateri. So you have electricity, so you have a capacitor inside to hold the electricity. So you boleh gunakan as a power bank, so you boleh gunakan dalam phone. Battery as the capacity. So similar, if you have a low thermal diffusivity, meaning the material can hold the heat. Kalau high thermal diffusivity, so dia akan release, dia tak akan simpan banyak, dia akan lalu. So that's the differences. Okay, so you can see the value. Thermal diffusivity kita selalu panggil as a alpha value. So heat conducted per heat stored. Berapa banyak dia dapat, berapa banyak dia simpan. Okay, so that's the differences in that. Okay, so material that has a high thermal conductivity or low heat capacity will obviously have a large thermal diffusivity. Okay, so high thermal conductivity and low heat capacity, maksudnya kebolehan untuk simpan tenaga is kurang. Okay, so it has a large thermal diffusivity. So you can see here, silver, gold, copper, aluminium. Tadi dia conduct, so it's a good conductor, but dia tak simpan. So it's a poor energy storer. Dia just bagi lalu je. Dia macam highway. Okay, larger the thermal diffusivity, the faster the propagation of heat into the medium. So dia akan dapat cepat, dia akan release pun cepat. Okay, a small value of thermal diffusivity means the heat is mostly absorbed by the material and only a small amount of heat is conducted further. Okay, so tadi dia lalu. So kalau small thermal diffusivity, it absorb most of it. Dia simpan dalam material tu. Okay, cuma a small fraction is released to the next level. Okay, so boleh tengoklah table dekat sini. So you can see all these are. So when you are designing something as an engineer, so nanti you all akan kerja as an engineer. So when you are working as an engineer, so let's say you need to design a system. So you don't only see the thermal conductivity of the material. So kena check juga thermal diffusivity. So let's say you already put diamond inside, so already spend so much, already asked the company to spend so much. CC, it cannot save the energy, it automatically release. Then company akan tanya, apa ni engineer, belajar dekat mana? Unimap. So don't be like that. So must have some kind of knowledge, okay, on all this. Okay, so you can see here some of the low diffusivity material. Okay, so you can see glass. Sebab itu glass, kalau you heat up in a microwave, so it will conduct it. After some time, it will just cool down. Kalau you letak dekat luar, because glass is having a low thermal diffusivity. Sometimes it can absorb. It can absorb. After some time, baru dia akan release. Okay, and water also. So if you heat up at 100 degrees Celsius, it will take some time. It will not happen within few seconds. It take a few minutes of hours. Okay, beef and also wood. Okay, all are having low thermal diffusivity. Okay, so this is generally on the conduction heat. So we see about thermal conductivity and also thermal diffusivity. Okay, so this is the example of question. So boleh cuba buat. Okay, so dekat sini ada lah. Okay, so these are the questions that can be asked. Okay, related to heat transfer on conduction. Okay, so we just go through. A flat wall is composed of 20 cm of brick having a thermal conductivity KT. So if the right face temperature of the brick is 900 degrees Celsius and the left face temperature of the brick is 20 degrees Celsius. So determine the rate of heat conduction through the wall per unit area of wall. Okay, so this suruh cari the heat conduction. So COND, so conduction, so over area. okay, per unit area over area. So you rearrange. So this is the only formula for heat conduction. Okay, so kalau disuruh cari value of Q over A, so you just bawa A ni ke bawah. So the remaining is K over the temperature gradient. Okay, so KT is given 0.72. So temperature different. So you lukis yang ni dulu. Okay, so this is the wall. So the right is higher temperature, so dia tinggi dari yang ni. So this side is 20. So T1 over T2. So 900 minus 20. So it's supposed to be in Kelvin, but since same unit, so you are just taking the differences, and it's 20 cm. So tukar ke meter 0.2. So you solve this, so you will get this reading 3168. Okay, so that's the rate of heat conduction through a wall per unit area of wall. Okay, so you can see another example. So try to do. Okay, baca dulu. Okay, roof of an electrically heated home is 6 meter long, 8 meter wide and 0.25 meter thick. Okay, bumbung dia lah. So bumbung dia adalah electrically heated. Okay, maybe in a cold country, so dia ada bumbung. Okay, so either bumbung akan jadi panas, ataupun ada setengah tempat tu di lantai jadi panas. Okay, so if you go to Korea, so dalam rumah dia ada thermal temperature controller. So you set the temperature controller, so lantai akan jadi panas. So when the floor become heated up, so the room temperature will be good. Okay, macam Malaysia kita on aircon sebab dia memang panas. Kalau lantai jadi panas, jadi oven, right? So here we are having a different mechanism, but in overseas, especially the northern regions, okay, macam US ataupun Canada yang ada salji kan. Okay, so during the winter, so they have this mechanism to heat it up. Okay, so either the floor heated up or the roof heated up. So dalam case ni, so it's an electrically heated roof. Okay, so dimension is given 6 meter times 8 meter times 0.25 meters. So isi padu dia kita tahulah. Okay, so thermal conductivity is given, K equals to 0.8. So the temperature of the inner and the outer surface of the roof for one night are measured to be 15 degrees Celsius. Okay, yang bagi tahu dululah. So dalam tu adalah 15, yang atas tu adalah 4. Because outside the upper part is more closer to the environment. The environment sejuk kan? Okay, so especially for a period. So you want to measure for the period of 10 hours. Okay, so the question is asking you determine the rate of heat loss through the roof that night. So dia nak cari berapa banyak heat is lost and the cost of heat loss to the owners if the cost of electricity is $0.08 per kilowatt hour. Okay, so ini adalah soalan dia. Okay, some of the assumptions made. So you are assuming that it's a steady operation condition exists during the entire night, since the surface temperature of the roof remain constant at a specific value. And the second assumption is constant property can be used for the roof. And here there are some assumptions. So sometimes even in your lab you can do assumptions that can help you with the calculation. Okay, so the analysis, okay, for the first part, noting the heat transfer through the roof is by conduction, and the area of the roof is 6 meter times 8 meter, so 48 meter square. The steady rate of heat transfer through the roof, and apply balik formula tadi. Okay, so K is given 0.8, so area is 48 meter square, so temperature difference is 15 minus 4, so L, okay, the thickness is 0.25. Okay, solve yang ni dapat 1690 watt, so equals to 1.69 kilowatt. Okay, so it's very direct lah, just replace the value. Okay, so the second part, the amount of heat loss through the roof during the 10-hour period and its cost. Okay, so heat transfer, Q dot ni apa? Q dot adalah rate of heat transfer. Okay, rate of heat transfer. So if you want to find the heat loss, so you kena kali dia dengan masa. Sebab yang ni per masa kan. Okay, so if you want to find 1.69 kilowatt, you times it hour. So you get the heat loss equals to 16.9 kilowatt hour. So ganti balik dengan formula tadi, the amount tadi. So 1 kilowatt hour is 8 cent. 8 cent. So you kali dengan 16.9. So for 10 hours of operation, so owner tu kena bayar $1.35. So dekat rumah kita pun kita kira macam ni lah. So meter yang ada dekat luar rumah, so it's calculating the energy, electrical energy based on kilowatt hour. So based on the previous month reading and current reading, you boleh calculate dah. So balik rumah tu you calculate. So tengok bil bulan lepas. So tengok, okay, so last month value air adalah okay sekian. Then you calculate. So you minus the current value with the previous value. You cuba kira berapa tarif. So I think Malaysia is 26 cent. 26 sen. Depends on the residential type lah. Shop lot different rate. So kalau you gunakan 3 phase current, different rate. So normal residential house I think 26 cent. Dia bermula dari 26 sen lah. So you try to calculate. So the similar way, even the electric man pun dia calculate sama. Dia ada machine. So dia akan compare dengan the previous reading, it will calculate, then you dapat bill. Okay, so that's one thing. Okay, so another example, so you can see here, the inner and outer surface of a 0.5 cm thick 2 meter times 2 meter window glass in winter are 10 degrees Celsius and 3 degrees Celsius respectively. If the thermal conductivity of the glass is 0.78, so determine the amount of heat loss through the glass over a period of 5 hours. What will your answer be if the glass were 1 cm thick? So yang ni dia sama macam tadi. Okay, so you are taking for a period of 5 hours. Okay, so you calculate the conduction heat transfer. Okay, the rate of heat transfer is Ka changes of T over L. Okay, 0.78 times with the area is 2 times 2. Okay, and the temperature is 10 minus 3 over thickness is 0.5 cm. Okay, bukan meter. So the in meter is 0.005. Okay, so you solve yang ni dapat the rate of heat transfer is 4368. Okay, so for a period of 5 hours, so you apply balik formula ni. So yang ni you convert to kilojoule per second. So bagi dengan 1000. Okay, because it's watt. So joule per second. Watt adalah joule per second. So you change to kilojoule per second times with 5 hours per second. So kali dengan 3600. Okay, so you cancel the seconds. So you will get 78620 kilojoule. Okay, so that's the amount of heat loss. Okay, so if the thickness of the glass double to 1 cm, then the amount of heat transfer will go down by half to 39310. Sebab dekat L ni, so instead of 0.005, it will become 0.01. So kalau yang ni dia bertambah, yang ni akan berkurangan. Okay, so the value will be half. So it will be separuh. Okay, another example. The aluminum pan whose thermal conductivity is 237 has a flat bottom with diameter 15 cm and thickness of 0.4 cm. Okay, so macam ni lah. So heat is transferred steadily to boiling water in the pan through the bottom at the rate of 800 watt. Okay, so kalau you panaskan dekat bawah, so heat is transferred from down to up. Okay, ke dalam. So if the inner surface of the bottom of the pan is at 105, so dekat sini adalah 105. So determine the temperature of the outer surface of the bottom of the pan. Okay, so you nak cari temperature dekat bawah ni. Okay, the analysis, the heat transfer area. So yang ni guna sebab kat bawah selalu bawah kuali selalunya bulat. Okay, so it's circle. So pi r square. So the area is 0.0177 meter square. So under a steady condition, the rate of heat transfer through the bottom of the pan is apply balik formula ni. Okay, so you substitute the value, find T2. So T2 you akan dapat 105.76 degrees Celsius. Okay, so this is how you calculate the conduction. Okay, so convection, so take 5. Okay, we will continue. Okay, we will continue with convection. So earlier we have seen about conduction. Okay, conduction. So this is convection, the second mode of heat transfer. Okay, total ada 3 mode. Okay, there are 3 modes. The first one is conduction, we have seen earlier. So and some of the calculation related to conduction. So this is convection. So what is convection? So convection is actually conduction, but you have a fluid motion to help the heat transfer. Okay, so kalau baca dekat sini, so convection is the mode of energy transfer between a solid surface and an adjacent liquid or gas that is in motion, and is involve a combined effect of conduction and fluid motion. So there the conduction is happening naturally. At the same time, you have a fluid motion involved. Okay, either it can be a liquid or it can be a gas or a wind or whatever. Okay, the faster the fluid motion, the greater the convection heat transfer. So that's why the result why we after we wash our clothes we hang it outside. Okay, one thing is, so you are having a conduction heat. The second thing is you have a radiation from the sun. The third thing is you have a convection heat transfer. Okay, because of the wind. So there's a wind. So because the wind is moving, so you have a fluid motion. So the stronger the wind is, so the faster the heat transfer will happen. Convection heat transfer. Okay, so in the absence of any bulk fluid motion, the heat transfer between a solid surface and an adjacent fluid is by the pure conduction. So if the fluid motion is not involved, so maksudnya, so it's not a convection, it's a purely conduction. Okay. So boleh tengok dekat sini. So you have a hot block. Okay, ada permukaan yang panas, and the heat is transferring, and you have a airflow. So because there's the airflow and the fluid motion is involved, so this is considered as a convection heat transfer. So kalau heat transfer wind ni tak ada, so this is only from the hot block to the environment, which is a conduction. Okay, a forced convection maksudnya, so you are using a fan, pump or any wind generator. So apa-apa yang hasilkan angin. Okay, it's artificial. So maksudnya buatan sendiri. Okay. So you are using, so that's why some of the experiment that you do for lab 4, so you are using fan, or you are using pump, or you are using something, okay, to generate wind. Okay, force, that's why we call it as a force. Okay, and natural meaning, so it is not artificial. So something can happen generally, maybe over time. So the heat is released, okay, or because of the environment. Kan dalam ni ada turbulence kan, air turbulence, because of that, so it's happening. But for it to be considered as convection, kena ada juga fluid motion. Okay, but it's general, not something yang you are still concentrating. Okay, so heat transfer process that involve change of phase of a fluid are also considered as convection because the fluid motion induced during the process, such as rise of water bubbles during boiling or fall of liquid droplet during condensation. Okay, so perubahan apa-apa macam cecair nak jadi gas. Okay, so fluid the liquid want to become gas or gas want to become solid. Okay, semua tu kita consider as convection because somehow or other, so there will be some fluid motion involved. Okay, kalau kita kita panaskan liquid, so after some time it will start to boil. Ada air bubbles. So air bubbles, that means there's a fluid motion. So we consider as a convection. Okay, so let's say you have a condensation. So dari cecair dia jadi because of cooling process. So that's the water droplets outside. Okay, water droplets outside, then the water droplet jatuh. So that's considered as a fluid motion because there's some movement. So all this transfer of phases, okay, inside the water or gas, so we consider as a convection. Okay, so how we calculate? So this is the formula. So convection heat transfer rate equals to H, surface area AS. So this is not a normal area. So this is a surface area, the area of all the surface. All the surface must be taken into consideration. The surface temperature minus the surrounding temperature. Okay, so nanti kita akan tengok macam mana nak calculate. So this formula is from Newton's law of cooling. So there's a formula generated by Newton. So we call as a Newton's law of cooling. So that is what we are using in finding this. Okay, you can see. So H in heat transfer for this is a convection heat transfer coefficient. Okay, sama macam dalam conduction tadi ada value K. So dalam convection is value H. Okay. Okay, so you can see some table. So some of the value of H for different process. So boiling and condensation, it has some higher value of H compared to free convection of gases. Okay, normally the forced one will have more lah compared dengan yang natural. So natural because it's happening by itself. Yang ni kita hasilkan. So when you hasilkan, dia akan jadi lagi cepat lah. So that's why kalau you letak sidai kain dekat luar, it will take 2 or 3 hours. So tapi kalau you letak dengan kipas, so you are increasing the value of H. So instead of 2 or 3 hours, dia maybe kain akan kering dalam masa 30 minit. Because you already increased the value of H. Okay, so see the example. Okay, so 2 meter long, 0.3 centimeter diameter electrical wire extends across a room at 15 degrees Celsius as shown in the figure. So ada electrical wire. So that's the electrical wire. So this is 2 meters and 0.3 cm diameter. The heat is generated in the wire as a result of resistance heating. Okay, so dalam ni ada current. Okay, so you have a current, so you have a surface temperature. Okay, 152 degrees Celsius. So voltage drop and electrical current. So current is 1.5 ampere and voltage drop is 60 volt. So disregarding any transfer by radiation, So determine the convection heat transfer coefficients for heat transfer between outer surface and the wire and the air in the room. So you make an assumption. Okay, so this is the formula. So for electrical, so the rate of electrical transfer kita panggil electrical power. Okay, electrical power adalah rate of electrical energy generated, so which is PV. The electrical power, so power is VI. So selalu saya ingat power is very important. So power equals to VI, very important. Okay, so VI, so you can calculate. So V is 60 voltage, I is 1.5. So the power generator is 90 watt. Okay, power is unit is what? The surface area of the wire is pi dl. Okay, because it's not circle. Okay, so it's not circle, so you need to times with the value of L, panjang dia. Okay, so pi d is 0.003 because tadi 0.3 cm. Okay, so please check the unit. Okay, and L is 2 meters. Okay, so the surface area is 0.01885 meter square. So Newton's law of cooling for convection heat transfer, okay, this is the formula. So you gantikan dalam formula. And because you want to find the value of H, so you replace whatever values that you already got. So Q, value of Q is 90 watt, As is 0.01885, and Ts minus T infinity, so meaning Ts is the surface temperature 152 and surrounding temperature T infinity is 15. Okay, solve yang ni you akan dapat 34.9, so 34.9 watt per meter square Celsius. Okay, so this is how you calculate. Okay, so another example. Okay, so a transistor with a height of 0.4 centimeter and a diameter of 0.6 cm is mounted on circuit board as shown in figure below. Okay, so you have a transistor mounted on the circuit board. Okay, so the transistor is cooled by air flowing over it with an average heat transfer coefficient of 30. The air temperature is 55 degrees Celsius and the resistor case temperature is not to exceed 70 degrees. Okay, so kita nak cari sampai 70 degree 70 degree Celsius. Okay, the air temperature, environmental temperature is 55. Okay, so you dapat sini diameter, so the thickness, the height is 0.5. So these are the information given. So you need to determine the amount of power this transistor can dissipate safely, disregard any heat transfer from transistor base. Okay, so ini adalah formula dia. Okay, so the surface area, if you see, there are two surface area involved. Okay, so cara nak kira surface area ni a bit tricky. So you need to know, you need to imagine. Okay, kalau you ada satu transistor, so dia ada surface keliling and surface dekat atas. So you need to find the surface, surrounding surface as well as on top. Okay, so kalau surrounding surface, kalau you buka, so you cut the surface, you buka, dia akan jadi square. Dia akan jadi square. Okay, so you gunakan pi dl. Okay, pi dl plus dengan on top. On top dia selalunya bulat. Okay, so you take pi r square ataupun pi d square over 4. So yang ni adalah segi 4, ini adalah bulat. Okay, so you solve this, so you can dapat, so the surface area is 1.037 times 10 to the power of -4 meter square. Then you can calculate the rate of heat transfer. Okay, so value of H is given 30. The area, surface area you already calculated, 1.037 times 10 to the power of negative 4. So Ts is 70. So the surface temperature, and the surrounding temperature is 55. Okay, so you solve this, you will get the rate of heat transfer is 0.047 watt. So the amount of power this transistor can dissipate safely is 0.047 watt. Okay, so this is how the calculation is made. Okay, so another final example for convection. Okay, so similar transistor, 4 power transistors, okay, ada 4, each dissipating 15 watt. Okay, so from each transistor 15 watt is dissipated, so mounted on a thin vertical plate, so 22 cm times 22 cm in size. So the heat generated by the transistor is to be dissipated by both surface of the plate to the surrounding air at 25 degrees. So surrounding air adalah 25 degrees Celsius, which is blown over the plate by a fan. The entire plate can be assumed to be nearly isothermal, and exposed surface area of the transistor can be taken to be equal. Okay, so the exposed surface area is equals to the base area. So base area tadi 22 cm times 22 cm. So if the average convection heat transfer coefficient is 25 degrees Celsius, 25 watt per meter square per centigrade. So determine the temperature of the aluminium plate. Dia suruh cari TS. Okay, TS. So disregard the radiation. Okay, first you need to find the total heat transfer. So 4 times 15, sebab ada 4, so each 15, so total adalah 60. Okay, so the surface area, so it says here the exposed surface area is equals to base area. So base area is 0.22 times 0.22, which is 0.0484. Okay, so dah dapat dua information. So you calculate the temperature. So you rearrange this formula, you akan dapat macam ni. So since you want to find the value of TS, so you rearrange formula ni dapat macam ni. So environmental temperature is 25. Okay, surrounding air is 25 plus Q is 60. So kali dengan tadi berapa? 25 is value of H. So value of surface area is 0.0484. Okay, you solve ni dapat the temperature is 74.6 degrees Celsius. Okay, so end of chapter 9 part 1. Kenapa lambat ni? Okay, so any question for chapter 9 part 1? I think we have one more part to cover, so which involve radiation. Okay, so we will see. So we already saw today related to conduction. So conduction and convection. So conduction is something related to physical contact, the heat transfer because of physical contact, and convection is actually conduction tapi dia ada fluid motion, okay, to assist. So if the process heat transfer process have a fluid motion, dia automatically jadi convection. So kalau tak ada fluid motion dalam convection case, so it's a pure conduction. Okay, so that's two things that we will see. So kita akan tengok satu lagi. So we will see one more, which is the radiation. Okay, so radiation. Okay, radiation Okay, radiation is the energy emitted by matter in the form of electromagnetic wave as a result of change in electron configuration of the atom or molecule. Okay, so to be simplified, so radiation is something that happen through the electromagnetic wave. Okay, macam matahari. Contoh adalah matahari. So matahari is few hundred thousand kilometers away from Earth. Tapi macam mana kita boleh rasa the heat of the sun? Because the heat is transferred through the electromagnetic wave in the vacuum, sampai dekat bumi, so kita dapat the heat. Okay, kita boleh rasa haba dia. Okay, so similar. So for radiation, the heat transfer is conducted through electromagnetic wave. Okay, unlike conduction and convection, the transfer of heat by radiation does not require the presence of an intervening medium. Okay, so kalau conduction nak berlaku, dia kena ada sentuhan. So kalau convection nak berlaku, dia ada syarat dia. Okay, so must have fluid motion. Okay, meaning there's still some kind of a contact. But radiation does not require any medium in between. Kalau vacuum pun still dia boleh lalu. Okay, so unlike conduction, okay, in fact heat transfer by radiation is fastest. So since it's using the electromagnetic wave, so dia gunakan speed of light. Okay, berapa cepat lampu boleh bergerak ataupun cahaya boleh bergerak, so that's the speed of radiation heat transfer. So radiation heat transfer is the fastest among all three. Conduction pun boleh lambat, convection pun boleh lambat, but radiation is the fastest because it's using the speed of light. And it will pass through vacuum. The vacuum maksudnya ruang yang tak ada gravity, ruang macam outer space, so we still can get. So this is how the energy of sun reaches the earth. So in heat transfer studies, we are interested in thermal radiation, which is the form of radiation emitted by the bodies because of their temperature. Okay, some of the body, okay, macam human body, so kita ada temperature kita sendiri. Okay, so we are radiating a temperature. Sebab itu kalau bilik itu sejuk, so let's say the temperature of the room is 20. So katakan dalam bilik itu ada 200 orang. So dia 20 degrees still, or we don't feel too cold. So katakan semua orang dah keluar, tinggal seorang je dalam tu. So we will feel, oh, kenapa tiba-tiba jadi sejuk? Is there something here? Ada makhluk gaib kan? So tiba-tiba seram sejuk kan? So it's because the radiation heat from our body is already less. So itu kalau you naik kereta api pun macam tu. So kalau you naik dari KL, so memang ramai orang. So turun dekat paling last dekat Alustar, ramai dah turun. You seorang nak turun dekat Arau, oh, orang dah kurang, so temperature dia tak turunkan. So tiba-tiba you pun feel shivering, because the radiation heat already lesser. Okay, so the other things that radiate their own temperature, macam X-ray, gamma ray, microwave, radio, even television pun, all these are not related to temperature. Okay, so electromagnetic radiation yang tak ada berkaitan dengan temperature, we don't take into consideration as radiation. Okay, so hanya yang ada temperature, so we consider as a radiation. All bodies at a temperature above absolute 0 Kelvin emit thermal radiation. Kalau your whatever temperature of the body is above absolute 0 or 0 Kelvin, so kita consider as a radiation. Okay, radiation is a volumetric phenomenon. Okay, so and all solid liquid gases emit, absorb or transmit radiation at varying degree. Okay, macam body. So for example, our body can absorb it. Okay, can absorb it, we can also emit radiation heat, and we also can transmit. Okay, all this can be done by the body. However, radiation is usually considered as a surface phenomenon for solid. Okay, so if the body is a liquid or gas, so it can emit or absorb. But for solid, for material ataupun macam table ke apa, so it only surface, it only happen at the surface. Okay, and tadi kita tengok untuk conduction we already have a formula. Okay, untuk convection kita gunakan Newton's law of cooling, and for radiation we use Stephen Boltzmann law. So that's a law formula yang Stephen Boltzmann dah create. So this is the formula. So the rate of radiation is siapa ni? Simbol apa ni? Rho. Rho surface area times with the temperature. Okay. So the radiation emitted by all surface is less than radiation emitted by the black body. So kalau boleh tengok dekat sini. So this is the value. So this value kita panggil as emissivity ataupun epsilon. So a measure of how closely a surface approximates a black body, for which so this emissivity is actually a value between 0 to 1. Okay, 0 ke 1. So in between all the materials we have a certain value. Okay, so kalau tengok dekat human skin is 0.95. Okay, so meaning black body tadi berapa? Black body tadi I think is 1. Okay, black body is 1. Okay, so the rest are lesser. Okay, so the radiation heat transfer you can calculate using this formula. Okay, so epsilon, this is rho, area, temperature. Okay, so we'll see some example. Okay, so this is the example. So consider a person standing in a room maintained at 22 degrees Celsius at all time. So meaning the room temperature is 22. The inner surface of the wall, floors and the ceiling of the house are absorbed to be at the average temperature of 10 degrees Celsius in winter and 20 degrees Celsius in summer. Okay, ni dah bagi dua temperature. So determine the rate of radiation heat transfer between the person and the surrounding surface if the exposed surface area of the average outer surface temperature of the person are 1.4 meters square and also 30 meters. So average surface dia manusia ni adalah 1.4 meters square and temperature adalah 30. Okay, 30. And because badan manusia ada temperature dia sendiri, so we will naturally emit. Okay, so we want to find out what is the rate of radiation heat transfer emitted. Okay, so nak kira macam mana? So there are two situations. One is for winter and one more for summer. So you kena kira asing-asing. Okay, so you just need to apply in the formula. To apply in the formula, so the epsilon, the value of epsilon, because it's a human skin, tengok balik dekat chart ni. Human skin berapa? Value dia. Uh, 0.95 human skin. So depends on the materials that you are dealing with. So you just need to substitute the value. So this, since this is a human skin, 0.95. Okay, so the epsilon, so this is given. Okay, mana tadi? So the value of rho is 5.670 times 10 to the power of -8. So I think I believe your calculator pun ada lah value ni. So value of rho. So you can start. So you just need to substitute. So here, so the surface area is given 1.4. Okay, so this is the temperature. So temperature in Kelvin. So temperature in Kelvin 30 tambah 273. So change to Kelvin to power of 4 minus 10. So winter temperature surrounding adalah 10. So minus 273. Okay, 10 plus 273. Apa benda ni? Okay. So don't know what is that. Heat transfer. Okay, so in winter the radiation heat transfer is 152. Okay, so similarly you calculate for summer. Okay, so summer you just replace, so you can get the value. So summer hanya berubah dekat sini, dekat belakang ni 25. So 25 plus 273, so you get 40.9. So here you can see the differences. So the differences in the heat transfer, okay, between winter and also the summer. Okay, so there can be simultaneous heat transfer mechanism happens. So heat transfer can happen at the same time. Okay, two things. So tadi kita tengok ada berapa mode. Berapa mode untuk heat transfer? Berapa? Ada berapa? So we have conduction, so we have convection, and also we have radiation. Okay, simultaneous means conduction and convection can happen together, macam tu. So two things can happen together. Kenapa benda ni ya? Is it like too panas? Okay, jangan letup sudah. Okay, so you can see here, so you have two modes. So you have radiation as well as conduction. Okay, here you have a conduction, you have a radiation. So you mix, you boleh dapat together. Okay, so depending on the situation, so it can happen together. Although there are three mechanisms of heat transfer, a medium may involve only two of them simultaneously. So walaupun ada tiga heat transfer mode, so normally it will have only two. Okay, maximum two or one. Okay, so example you can see here. So in a room, so you have a human being. So you have a room with the temperature. Here you have a radiation temperature radiated from the human body, as well as a convection heat transfer. Okay, so similarly here. Okay, so summary of heat transfer process you can see here. Okay, conduction, convection, and also radiation. How heat is transferred? So in conduction is between molecule, meaning because of physical. Convection, so you have molecules that move. Okay, from fluid motion, so it's involved, and radiation is based on electromagnetic wave. Okay, so the medium in conduction is solid, and fluid is mostly static fluid. Okay, and for convection, so it's involving a moving fluid, and radiation, it does not require any medium. Tak berkaitan. So even vacuum, it still can transmit radiation. Okay, so laws involved. Okay, for conduction, so Fourier's law of heat conduction. Okay, for convection we are using Newton's law of cooling, and for radiation we use Stevens-Boltzmann mostly. Okay, and we also use some of Kirchhoff law. Okay, Kirchhoff law, I think you remember Kirchhoff law. Okay, take 5, then we will try to complete this. So we will continue. Okay, few more slides. Okay, steady heat conduction in plane walls. Okay, dinding. Okay, heat transfer melalui dinding. Okay, so you can see. So heat transfer through the wall of a house can be modeled as steady and one dimensional. Okay, so it can be steady because so kalau tengok is one side is 30 and another side is 3, so it's steady. So over time, over the surface, and it's one dimensional, meaning it's only one direction. Okay, so either dari luar ke dalam ataupun dari dalam ke luar. Okay, the temperature of the wall in this case depends on one direction only, say the x direction, and can be expressed as Tx. Okay, so normally the transfer heat conduction ataupun heat transfer through the wall is depending on the thickness of the wall. Kalau lagi tebal dinding tu, so the heat transfer will be reduced. Okay, so heat transfer is the only energy interaction involved in this case, and no heat generation. Okay, so meaning you are just transferring the heat, you are not generating new heat. Okay, so Q in minus Q out adalah the rate of change of the energy of the wall. Okay, apa yang ada dekat sana lah. Okay, the energy that is available. Okay, so in general, so we are using the conduction heat transfer rates formula. So negative Ka dt over dx. So this we call as a Fourier law of heat conduction. Okay, so kalau you integrate and you extend the formula, so at the end you will get this formula that you can use for your calculation. So conduction heat transfer of wall equals to Ka T1 minus T2 over L. So L is the thickness. So kalau thickness tinggi, so yang ni akan rendah because it's inversely proportional. Okay, so ini adalah explanation dia lah. So the rate of heat conduction through the plane wall, okay, yang ni Q conduction wall is proportional to the average thermal conductivity. So K, so kalau yang ni tinggi, K pun akan tinggi. The area of wall and temperature different, T1 minus T2, but it's inversely proportional to the wall thickness, so L. Okay, so you boleh gunakan formula ini untuk calculate. Okay, so that's on the wall. So we also have a thermal resistance concept. Okay, apa tu resistance? Apa tu resistance? Yeah, resistance. Yeah. Tak dengar? Rintangan. Okay, so dalam bahasa Melayu adalah rintangan. So thermal resistance concept maksudnya konsep yang menghalang thermal conductivity. Okay, so thermal resistance. So heat conduction through a wall, so kita dah tahu gunakan formula ni. Okay, so the resistance is R wall equals to L over Ka. Okay, so kalau you pecahkan formula ni lah. Okay, so you boleh gantikan. So L over Ka, so you can replace with resistance. Okay, so for wall ataupun conduction resistance, so we call as a resistance thermal resistance of wall against the heat conduction. So kita gunakan formula ni. So for conduction we use R equals to L over Ka. So yang ni dari formula ni lah. Okay, so we can relate it with the electrical current ataupun electrical resistance. Okay, so electrical resistance apa? V equals to IR kan? So R adalah V over I. So V over I. So you boleh gunakan relation of this formula to find the resistance. So boleh tengok dekat sini. So this is your thermal. So thermal from between temperature 1 and temperature 2, you have a thermal resistance R. So which is this formula. And for convection, from here we can get the formula. The R for convection is 1 over H AX. So tadi kita tengok untuk conduction, ini adalah formula dia. For resistance, R wall ataupun R conduction equals to L over KA. Untuk convection, so R convection equals to 1 over H AS. Okay, so kita boleh we can utilize this for our calculation. Yang ni kita panggil as convection resistance. Okay, so thermal resistance network. So if you want to measure between one point to another point through a wall, so katakan start dekat sini. Okay, so ini adalah temperature temperature surrounding of one side. This is the other side. So here you have T1, which is the first contact point, then T2, then is going. So perjalanan dia, so surrounding temperature 1 ke T1, so T1 to T2, T2 to surrounding temperature 2. Sebab tu you dapat macam ni. Okay, so here you have this side is convection, so here inside is conduction, and the other side is convection. Okay, so you replace with the formula yang kita dapat tadi, kita akan dapat formula dia macam ni. So R total equals to R convection plus R wall ataupun R conduction plus R convection 2. So gantikan balik dengan formula tadi. So 1 over H1A plus L over KA plus 1 over H2A. So yang ni kita boleh kirakan R total. Okay, R total, so kita boleh carilah. So macam mana kita nak dapat. Okay, so this is for multi-layer wall. So tadi kita tengok between wall, then we check about the thermal resistance. So katakan multi-layer wall. So dinding yang ada tu ada banyak layer. So katakan ada batu, kemudian ada besi. So different layers. So for different layers, kita ada different calculation. So itu yang kita dapat tahu dekat sini lah. Okay, so we can see here. So surrounding temperature 2.1, then wall 1 different material, wall 2 different material. Selalunya kalau ada different material, so we have different different property ataupun different density. So different material maksudnya different density lah. Okay, so ini adalah formula dia. So for you to find T1 dekat sini, so in between here kita ada few point. So T surrounding 1, so temperature 1, temperature 2, temperature 3 and temperature surrounding 2. Okay, so to find T1, so you cari between T surrounding 1 minus T1 over convection. Sebab yang ni surrounding is a convection, so you gunakan convection punya formula. And to find T2, so kita start dari sini sampai sini ataupun dari T1 sampai T3, T1 to T2, so depends on which value you have, then you ambil the respective. So kalau you ambil dari sini, you ambil the resistance here also. Kalau you nak ambil dari sini ke sini, so you just ambil T1 minus T2 over R wall 1. So you boleh dapatkan the value of T2. So kalau you nak cari T3 value dekat sini, so you ambil T3 minus T surrounding 2 over R convection 2. Okay, depends what formula you want to use. So jadi kita boleh carikan the value of T1, T2 and T3. Okay. So the generalized thermal resistor network, Okay, so at times, so tadi kita tengok the walls are vertical. So kita boleh cari, okay, dari point ni ke point ni macam ni. So there can be a situation where the walls can be different vertically, not horizontally. So macam ni lah. So different properties. Okay, different properties. So in this case, kita kena gunakan parallel resistance, macam dalam elektrik. So in electric, we find resistance in parallel and also resistance in series. So similar lah. So kalau macam ni, dia series. So this is resistance in series. So you can just plus. You can just plus like this. Okay. But if the resistance differs between materials at vertical levels, meaning is parallel, so you gonna gunakan parallel formula. So 1 over R total equals to 1 over R1 plus 1 over R2. Dekat sini lah. So gunakan konsep ni. So similar like electrical. Okay, so electrical. Okay, so R total you will get R1 R2 over R1 plus R2. So you akan dapat macam ni. Okay, so that's one thing. So okay, consider combined series. So we also can have a combined series. Okay, so this is parallel, then this is series. So like how you do in electrical analysis, so you gabungkan yang ni dulu, then you baru you tambah dengan yang ni. So similar like this. So R total is R12 plus R3 and then R convection if necessary lah. So you combine this, you will get R1 R2 over R1 plus R2 plus dengan R3. Okay, so all this you can use in your resistance analysis. So similar like how you are doing analysis gunakan Kirchhoff law semua tu kan. So you can use the similar thing in calculating the heat transfer. Okay, so you can try all this. Okay, so you have a few questions here. Try it yourself one. Okay, so answer saya dah bagi. Okay, so you try yourself. Okay, so whether you can get this answer. So yeah, I think I have 4 or 5 questions for you to try. Okay, so semua pun saya dah bagi answer. So I already give the answers. So try to find. So like this case, this is only a single wall. Okay, so try to find the heat transfer between these points, and this is also a single wall. Okay, and glass, but you have two different. You have a convection here, and this is multi-wall. Okay, two different wall type, glass, air, and also glass. Then you have this is combination. So you have a vertical wall as well as different horizontal wall. Yang ni lagi lah. So it's a combination. Okay, so try to get all these answers. Okay, try yourself lah for your preparation for your final. Okay, final maybe akan ada soalan ni, soalan jenis ni. Okay, so you need to know. That's why I put try it yourself. Okay, so with that, so we conclude chapter 9. So we already conclude all the chapters. Okay, so if you are not sure about this heat transfer, so listen back to the video. So all the videos of recording of our class discussion, semua saya dah letak dalam Google Classroom for your convenience. Okay, so try to listen back. So you have a few more weeks to go. I think the final schedule dah keluar. Okay, so our exam will be on 7 hari bulan December. So plan your time. So I think we have like 2 or 3 more weeks for you to prepare. Okay, so we will do exam clinic. So